Hi everyone, in this video I want to talk about how to find a closed form expression for a given sequence. So the sequence that I'm working with here is 1, 1, 2, 4, 7, 11, 16, etc. So the first thing I'm going to do is I'm going to look at the first sequence of differences. Okay, so to get the first sequence of differences, I'm going to subtract the terms. I'm going to look at what's the difference between 1 and 1. Well, that's 0. Next, what's the difference between 1 and 2? If I subtract those 2 minus 1, I get a 1. Keep going. 4 minus 2 is 2. 7 minus 4 is 3. 4, 5, 6, etc. All right, I don't have a constant sequence yet, so I got to keep going. So now I'm going to look at the second sequence of differences. So to get the second sequence of differences, now I'm looking at the difference, again, between the terms, and 1 minus 0 is 1. 2 minus 1 is 1. Oh goody, I'm getting a constant sequence here. So now I'm going to stop. Roughly looks like that. It's a terrible drawing, but you get the idea. So the idea is that once I get the constant sequence, I stop. And since this was a second degree sequence of differences, I'm going to need a second degree polynomial. So I'm going to need something of the form f of n, like a function of n, is some constant a times n squared plus b times n plus c. And my job is to figure out what is a, what is b, and what is c. Okay, so when n equals 1, my little formula here for the polynomial would be f of 1. If I plug in n equals 1, I would get a times 1 squared, well that's just going to be a, plus b times 1 plus c. Okay. What that gives us, it gives us a plus b plus c. All right, so that's the deal when n equals 1. But I also know what's going on when n equals 1. I'm supposed to get the first value of my sequence, which is 1. All right, so I've got an equation, a plus b plus c equals 1. When n equals 2, I'm going to plug in n as 2. So f of 2 would give me a times 2 squared plus b times 2 plus c. If I work that out, that would be 4a plus 2b plus c. And I know what's going on when I've got n equals 1. I'm looking at the second item in my sequence, which is also a 1. Okay, so I've got another equation here. Now we can keep going and look at n equals 3 and so forth, but I don't need to go too far. Notice that I've got to figure out 3 values, a, b, and c. So since I've got 3 unknowns, I need 3 equations. Okay, and it's always going to be one more than the degree of your polynomial. So I had a degree 2 polynomial because my second degree differences were constant, so that was a 2. One more than that gives me the 3 unknowns, 3 equations. I've got to do one more trip through here. When n equals 3, here we go, f of 3 is going to be a times 3 squared plus b times 3 plus c. And if I work that out, that'll give me 9a plus 3b plus c. And if I go up here in the sequence, the original sequence, and I look at the value for the third term, that's going to be a 2. All right, so now I've got 3 equations and 3 unknowns. You can sit down with algebra and solve this, but I don't recommend doing that. For the purposes of our course, we're really just trying to look at the big picture and this is not an algebra course, this is a discrete math class. So you can fast forward those calculations by going to an online equation solver. So I like the Wolfram Alpha Online Systems of Equations Solver. So I'm going to clear out what's going on here and type in my own system well, now see, we've got 4 equations. I don't need that. I only need 3 equations. Okay, here we go. So our first one we said was a plus b plus c equals 1. Our second equation was 4a plus 2b plus c equals 1. And the third equation was 9a plus 3b plus c equals 2. And so the computer did interpret my equations correctly. And what it told us is that a equals 1/2, b equals -3/2, and c equals 2. So let's go back to what we have. And we were looking for this quadratic equation. And I now know what to put in for a, for b, and for c. So let's write down our answer. Our answer is f of n. We have a function of n. A was equal to 1/2. B is -3/2, so I'll put that in here, -3/2. And C was 2. And if you plug in various values of n, like if I plugged in n equals 1, 2, 3, 4, like if you plugged in n equals 5, you should end up with 7. So you could go through and check your work.